In speech transmission, we send the speech from the some receiver, and the speech is transmitted through different paths, including the different media, and the finally receiver receives the speech, and the phase between the speech by the sender and the received by the receiver, it consists of the different phases. In this section, in speech transmission, we study about this section. First, we look at it that the area of the speech transmission deals with the efficient coding of the speech signals to allow the speech sound transmission at a low transmission rates over the network. It is because that when we transmit the speech at a low transmission rate, the speech signals get accurate at the receiver side, and there is no noise hindrance that occurs in this phase. So the speech is transmitted generally at the low rate, and it is also the fact that the power used during the transmission of the speech is always cost low. The second point is, secondly, we look at it that the goal is to provide the receiver with the same speech sound quality as the generated at the sender side. When we transmit the signal at a very high speed, then it may be happen that some signals may lose when the receiver receives the signal, due to which we generally transmit the audio signals at the low speeds. The principles that are connected to the speech generation and recognition systems are: when we transmit the signals over the network, firstly we calculate the size of the audio format which we have delivering. For this, we use following approximates, that we use the signal form coding. In the signal form coding, the goal of the signal form coding is to achieve the most efficient coding of the audio signals, which is generally done by the given formula that we have. If we have the sampling rate, resolution, sampling rate is generally measured in a sample per second or hertz. Resolution is bits, resolution represented by the B, and C is the number of the channels, 1 for mono and 2 for stereo, and D is the recording duration, it is second. And from the resolution formula, the size is calculated as when the size of the audio signal sample is large, it gives the good quality sound, but due to the large size, it gives the high resolution, and which is very much effective to us. Let us see the example. In the example, we have given that the 10 if we record a 10 second of the stereo music at a 44.1 kilohertz, which has given the resolution of 16 bits, the sample will be to our formula. The given values are the sample values are we place in their position and perform the calculation, and there is a conversion unit for the different units. We generally represents the size in a MB. MB, we generally use the MB size file, which is converted as 1 kilobyte equals to the 124 bytes, and 1 megabyte equals to the 124 kilobytes. Okay, then the next speech generation and recognition principle occurs in the source coding. In the source coding, generally the analog signal is of at the beginning stage, the analog signal is converted into the digital signal using analog to the digital converter. Then then speech analysis process occurs, in which we search about the certain things like who is delivering the speech, and about what topic he is delivering the speech, and how it is delivering the speech analysis process is done, and the the output of the speech analysis is generally in the form of the coded speech signal, which is then reconstructed. In the reconstructed phase, the analog signal, which is in the form of the certain peak sharps, maybe in the discrete form, then it is converted back to the in the receiver side, that which what was the information that was transmitted, it is converted, or it is the reversing process. Then finally the digital to analog converter converts that digital sampled value into the analog form, which is generally in the form of the different signals or waveform, and finally receiver receives the signals. Let us see what is in the source coding. Parameterized system work with the source coding algorithms. Here the specific speech characteristics are used for the data rate reduction. We already discussed that at the low data rate transmission, the signals are we transmit that are accurate, and the signals is divided into a set of the frequency channels during the speech analysis, because the only a certain frequency maxima are relevant to the speech. The speech transmission, the frequency for the, maybe there are the lots of the frequency that's causing the spikes, which may cause the certain noise in the signals. Noises are we reduce them in the certain maximas or certain values, that this is the peak value, and above that are always cut off at the log diagram shows us that the source coding from the analog signal, speech signal from the sender to the receiver end. And the next phase comes along that the speech synthesis methods, speech recognition and synthesis method. In this phase, at the beginning, the recognition of the speech is done, which is at the center side. In this phase, we discuss that who is delivering the speech, about what he is delivering and how he is delivering. These things are collected, and signal is transmitted over the network generally in the digital form through different mediums, and at the receiver end, the synthesis process, that which signal in the form of the 0 or 1, that is synthesized back to the audio form, and the analog speech is delivered at the receiver side. And generally the transmission, generally during the transmission, the main important characteristics like the loudness, intensity, sampling rate are transmitted, which are generally called the speech elements, which gives us that the at a low transmission rate we can send the best quality audio signals over the transmission lines. Okay, and finally the achieved quality, when the sender sends the audio signals, the receiver receives that audio signal, and the quality is also measured. The quality, we have seen the graphs that achieved quality versus their data rates. Let's define the essential, the minimal data rate for a given quality. The figure shows the dependence of the achieved quality of the compressed speech on the data rate. The figure shows that there is a y direction plotted as a achieved quality, and in the x direction there is a rate. That the different eras shows that in the 1980s 2 kilobytes is poor for the achieved quality over the transmission rate, and the during the phase occurs in that year 1980, the 16 bits or 32 kilobits per second transmission rate was good for the achieved quality, and during the evolution occurs generation to generation. In look at the graph that year 2000, the 8 kilobytes data is sufficiently or good for the transmission rate, which is the achieved quality during the generation to generation. And we always try to transmit the audio signals at a low rate, because we have already discussed that why. And the figure shows that the audio quality and bit per samples, the ratio shows that the different signals like the audio CD signals or telephone signals, which is achieved, how many bits are transferred over the audio signal finally, which is achieved at the receiver side. The figure shows the dependency of the audio quality on the number of the bits per sample value. For example, excellent CD quality can be achieved with the reduction from the 16 bits per sample value to a 2 bits per sample value. This means the only 1/8 of the actual data needs to be transmitted. We discussed that previously. We discussed that the actual data side at the sender side not completely transmitted over the receiver side, but the certain portions like the characteristics of the sound are always transmitted over the receiver side. The graph shows that 1/8 of the actual data needs to be transmitted, and this is the graph of the dependency of the audio quality on the number of the bits per sample value. And thank you.